Good morning, class. Today we are going to be looking at mechanical energies, and if you remember from last week, there are two main types of mechanical energy, or there are only two types. Anyone want to tell me about the first one? Potential energy. Energy that is stored. This is also called gravitational potential energy. If I drop this ball, at the moment it's gravitational potential energy. Correct. Kinetic energy. Kinetic energy is mass in motion. Do you think he's demonstrating kinetic energy as he's pedaling the bike and moving? The bike is moving. Good one. Well done. What about this guy on a hot rod motorbike? Do you think he has good kinetic energy? Which car do you think is going to make the most kinetic energy? Think about putting it in our brains, our types of energy. And let's move on. The next thing we're going to look at is the law of conservation of energy. Now, energy cannot be created nor destroyed. Energy changes from one form to another. Anyone like to give me real life examples of that one? If I'm running along flat out, is my energy from my feet transferring into the pavement? When I stop, does my energy stop? No, it changes from one form to another. Potential energy and gravitational energy equal mechanical energy. Well done. If you have been following along and can make meaning, you can probably answer both aims of the experiment we are about to complete. Let's collect the evidence we need via an experiment to collect the information to prove our theory. Aim 1. Using the law of conservation of energy, can potential energy be converted to kinetic energy? Yes, it can. Aim 2. What is the difference between potential and kinetic energy? Let's complete the experiment and explore the answer. I have set up an experiment using polypipe and a marble to explore the speed, direction and momentum of the marble. We will need to record our data for analysis, make conclusions about our results and recognise patterns and consistent physics ideas. Let's get into our experiment groups. Remember, we need a manager, a recorder, a resource person, and the very most important person who supports all of those roles. Something to remember when we are dealing with conservation of energy, the path taken by the object can be ignored, and you may like to research this further as we continue with our studies. Don't forget, the important things to remember are that the object's velocity, so its speed and direction, which is its kinetic energy, and the height, the starting point, which is its gravitational potential energy. So here we have our 5 centimetre height, and we need the timer, the stopwatch. If you hold on to the stopwatch for me, and start. That was 1 minute, 1 second 9. Good job. Excellent. Okay, writing that down. Second attempt. Start. That was 1 second and 0.8. Good job. And ready, Tana?
Yeah.
Start. Students will have modelled by the teacher 5 centimetre and 15 centimetre heights for the poly pipe to begin at. Recording results is also demonstrated. Our last idea. What is the velocity and what does this mean for kinetic and potential energy? So as you head off in your groups, can you please consider this question? You have 5 minutes to set up and 10 minutes for testing and recording, and then we will come back and share our results. And I would like to read out for you what Group 2 came up with as their conclusion. Can you please compare it to your conclusions? You can add to the notes if you'd like to. I was impressed with their results. The activity with the marble rolling down the pipe shows very nicely the conversion between gravitational potential energy and kinetic energy. In the first instance, the pipe was held relatively low, and therefore the gravitational potential energy was also relatively low. The kinetic energy at this point was 0, since the marble wasn't moving yet. When the marble rolled out of the other end of the pipe, it was moving relatively slowly, and therefore its kinetic energy was also relatively low. At this point, its gravitational potential energy was 0, since it was at 0 height above the tabletop. What do we think about that? Who had differences of opinion? In the second instance, the marble started off higher up, and therefore its gravitational potential energy was higher. By the time it got to the bottom of the pipe, its gravitational potential energy was 0 height above the table, but its kinetic energy was high, since it was moving much faster than the first time. Therefore, the gravitational potential energy was converted completely to kinetic energy. What do you think we should remember to add there? Any information about the conditions? Do you think the poly pipe width might make a difference? Do you think the poly pipe might have friction? I really liked Group D's response for their conclusion to their comments. In this case, the pipe being held higher, the gravitational potential energy at the start was higher, and the kinetic energy, okay, so that includes velocity, doesn't it? Of the marble was higher at the end. In other words, the total mechanical energy was higher and only dependent on the height you held the pipe above the table, and not on the distance the marble had to travel through the pipe. So do you think they've reached some strong conclusions?
Yeah.
Is there any experiments that you would like to try next to compare and reason their arguments and their conclusions? Yep, good idea. Do you think that we should be trying that one? Would you like to go and get the smaller piece of poly pipe now?
Teacher, my iPad's glitching, so if it just keeps on going like up and down.
Thank you.
Green.
Thank you. We'll see how we go. This is the end anyway. You guys, you groups can come and collect a shorter piece and we will compare the distance rule that we have decided on. Thank you. Off you go. We'll come back together in about 10 minutes.